Watch a solid wooden log violently breaking down into smoke and ash inside a fire. It looks like the physical matter is being destroyed. We can test the mechanics of this destruction with a foundational physical thought experiment. Imagine placing that same combusting log inside a completely sealed, thermally isolated glass reaction chamber and setting the entire apparatus on an ultra-precise digital scale. As the wood ignites, consumes oxygen, and completely collapses, the number on the digital display remains completely static. The total weight does not change whatsoever. This cross-section diagram illustrates the mathematical equality at work. The final physical mass of the remaining ash, the released carbon dioxide, and the water vapor perfectly matches the combined mass of the initial wooden log and the oxygen it consumed to burn. We intuitively perceive a burning object as vanishing into non-existence. The physical reality dictates that the materials simply reorganize their structure without losing a single atom. In 1789, chemist Antoine Lavoisier proved this relationship by performing meticulously weighed combustion experiments in closed vessels. He demonstrated quantitatively that matter is only ever rearranged, never destroyed. We can see this strict physical ledger operating inside the human body, specifically when we examine the physiological process of weight loss. People frequently assume that when they burn body fat, the tissue converts into empty space. To process 10 kilograms of stored lipid molecules, exactly 8.4 kilograms physically exit the body, exhaled from the lungs as carbon dioxide gas. The remaining 1.6 kilograms of fractional mass is expelled as liquid water through sweat and tears. Biological existence operates under a rigid ledger. The human body cannot make its own mass convert to empty space. Every single atom of fat must be physically processed and pushed out into the surrounding environment. Albert Einstein expanded this ledger in 1905, unifying the concepts of mass and energy into a single interchangeable framework. This typographic animation of the equation E equals mc squared demonstrates the relationship. Mass represents concentrated latent energy, while energy functions as liberated dynamic mass. We can measure the weight of this stored energy in modern consumer electronics. A fully charged smartphone battery possesses slightly more physical mass than a battery that is completely drained. When a phone absorbs 15 watt-hours of electrical charge, that energy is stored as chemical potential. It rearranges the spatial configuration of the lithium ions, adding a microscopic yet mathematically absolute fraction of a gram to the device's total rest mass. If we look back at our burning wooden log, the intense thermal heat radiating into the room is actually carrying away an undetectable amount of the log's physical mass. The mass conservation observed by Lavoisier and the energy equivalence mapped by Einstein operate as unified aspects of a single cosmic currency exchange. Classical and relativistic physics map out how this universal ledger balances, but we have to look deeper to understand why these strict conservation laws exist in nature at all. In 1918, mathematician Emmy Noether provided the underlying explanation. She published a theorem linking continuous physical symmetries directly to universal conservation. Noether based her work on time translation symmetry. This is the foundational principle that the basic rules of nature remain constant, operating the exact same way today as they did yesterday. Because space-time operates with this uniform symmetry, the conservation of energy is a mathematical inevitability. Her theorem establishes conservation as the inescapable architectural bedrock governing the dynamics of every physical system in reality. We can apply these rigid conservation principles to modern macro systems and see how they dictate the limits of industrial engineering. A battery electric vehicle operates as a practical accounting system. Every drawn joule must rigorously balance across useful propulsion, internal storage, and environmental waste. This flow diagram tracks the entire energy loop. A 100% grid input splits. One fraction converts to forward momentum, while the remainder bleeds away as thermal friction. As the vehicle slows, regenerative braking claws back kinetic energy, returning it directly to the battery ledger. True sustainability is the act of abandoning linear waste systems and aligning human engineering directly with the inescapable closed-loop boundaries of the physical universe. The human mind operates within the exact same thermodynamic boundaries as a burning log, consuming chemical energy to power cellular repair and cognitive processing. On a biological balance sheet, every focused thought draws directly from the body's finite metabolic reserves, the same ATP fueling physical movement. This energy input must balance against useful work, glycogen storage, and the parasitic waste of stress. Treating cognitive capacity as an infinite emotional resource creates a systemic deficit. Because the brain is a physical organ subject to the laws of energy conservation, focus functions as a strictly conserved, exhaustible biological currency. You can navigate these limits by designing closed-loop workflows, minimizing the friction of daily processes, and structuring routines so that the output of one task recycles directly into the next. We can never cheat the universe's strict physical ledger. But by accounting for our inputs and outputs, we achieve peak performance by honoring the continuous dance of matter and energy.